Children, today we are going to discuss the topic increasing and decreasing functions. So here I have drawn the diagram, and if you see that there is a function which is a continuous function, and it is also derivable in the interval a and b. So we can see that in the interval a and b, at every point, if we draw a tangent at any point, if you draw a tangent in the interval a and b, then that tangent will form an acute angle with the x-axis. So the value of tan psi will be greater than 0, because when the value of tan is lying in between 0 and 90 degree, the value of tan theta will be positive. So here the value of psi is lying between 0 and 90 degree. So the value of tan psi will be positive, or we can say that the slope of all the tangents between the interval a and b will be positive, right, children? So whenever this happens, that the slope of the tangent is positive, then we can say that the derivative or the value of the derivative between a and b is positive, right? So when this happens, we can say that the function is strictly increasing, right? So when the function will become increasing, let's discuss the condition. If the function is continuous in close interval a comma b and derivable in open interval a comma b. So from here the function must be derivable in the given interval, right? And the first condition, which we have formed from here, that if the derivative of the function is either greater than or equal to 0 for all x belongs to the value lying between a and b, then f is increasing in the closed interval a comma b. And if f dash x is greater than 0 for all values lying between a and b, then f is strictly increasing in the closed interval a comma b, right? If the slope is become 0 at certain point, then the function will become increasing, and it will, if always remains greater than 0 at every point in between the interval a comma b, then the function will be strictly increasing, right? And increasing means the slope is positive, right? And when the slope is either less than 0 or equal to 0 for all x belongs to a comma b, then we can say that the function is strict, right? If f dash x is less than 0 for all x belongs to all the values between a and b, then f is decreasing in the closed interval a comma b. Okay, and the last condition says that if f dash x is less than 0 for all values between a comma b, then f is strictly decreasing in the closed interval a comma b, right, children? So when the slope becomes either less than 0, right, then or equal to 0, then the function will be decreasing. When it is always less than 0 in the interval for all values lying between a and b for the given interval, then the function will be strictly decreasing. Less than 0 means the tangent is forming an obtuse angle with the x-axis. That means with the value of the angle is obtuse, right? Then tan theta will be between 90 and 180 degree, and whenever tan lies in second quadrant, it is negative, it has a negative value, right? Note down this first. Now let's see few sums, children. In this sum it is given that prove that fx equals to 3 plus 1 upon x is strictly decreasing, right? We have to prove that the given function is a strictly decreasing function, right? So the value, see the solution, fx is 3 plus 1 upon x. If we differentiate the function with respect to x, we get the value of f dash x as minus 1 upon x square, right? Now we know that, children, the value of x square is always greater than equal to 0 for all real values of x. So if we multiply minus sign both sides, we'll get minus x square less than equals to 0 for all real values of x, right? And when we do the reciprocal, you know that x cannot be equal to 0, because this whole term will become not defined. So the value of minus 1 upon x square will be less than 0, right, children? So now we have proved that the value of f dash x is less than 0. That means for all values of x, that means if the function fx is strictly decreasing, right, children? For strictly decreasing, f dash x must be less than 0. Alright, note down please. Let's see another sum, children. In this sum, the question says for what value of k the function fx equals to kx cube plus 5 is decreasing. Right, decreasing means the value of f dash x is either less than or equal to 0. Let's see the solution. Fx equals to kx cube plus 5. When we differentiate fx, what we will get? F dash x as 3kx square and 5 will become 0. Now, children, we know that the value of x square is always greater than equal to 0. So, the value of f dash x will be either you'll get positive value here or 0. So, the value of f dash will be either 3k plus or 0, right? So, to prove that, to find the value of k, the function is decreasing. To make this function decreasing, the value of f dash x must be less than 0. So what we know that plus we have to make this whole term as less than 0. Now what we'll do, if the value of k is less than 0 or negative, then we know that f dash x will be 3 into negative into positive. It will be negative value. So we can say that the value of f dash x will be less than or equal to 0. So we can say from here, we can conclude from here, f dash x will be decreasing if the value of k is less than 0. Right, children? That means for this value, fx will become a decreasing function. Note down the solution, please. Let's see another sum, children. Now here the question says prove that the function f given by fx equals to log cos x is strictly decreasing on open interval 0 comma pi by 2. Right, we have to prove that the function is strictly decreasing. For strictly decreasing, children, the condition is f dash x is less than 0 in the given open interval. Right, let's solve, children. Fx equals to log cos x. So when we do the derivation, find the derivative of fx, it will become f dash x equals to 1 upon cos x, and dy dx of cos x is minus sin x. So minus sin x upon cos x will become tan x minus tan x. Alright. So finally we got the value of f dash x as minus tan x. Now children, we know that the interval 0 to pi by 2, that means the first quadrant. In first quadrant all the trigonometrical ratios are positive. So the value of tan x is also positive. So we can say that tan x is greater than 0 for all x belongs to open interval 0 to pi by 2. Again, if we multiply minus both sides, the sign of the inequality will change. That means the value of minus tan x will be less than 0 for all x belongs to open interval 0 to pi by 2. And this is the value of our f dash x, the derivative of the function or the slope of the function. That means the slope of the function is negative. So when the slope of the function is negative, that means it is strictly decreasing in the given open interval. Right, children? Note down the solution, please. Let's see another sum, children. Now in this sum, the question says find the interval for which the function x square minus 4x plus 6 is strictly increasing or strictly decreasing. Right? We have to find the interval for the function to be strictly increasing or strictly decreasing. The function is x square minus 4x plus 6, right? Now, if we find the derivative of the function, that is f dash x, it will be 2x minus 4. When we take 2 common, it will be 2 bracket x minus 2, right? Now, if the function is strictly increasing, that means the value of f dash x is greater than 0, all right? The value of f dash x is greater than 0. So it will become greater than 0. This term will become greater than 0 when x minus 2 will become greater than 0. When we transfer to that side, it will become x is greater than 2. We can represent this range as this interval as x belongs to 2 comma plus infinity. Greater than 2 means up to infinity plus infinity. So from here we can write the statement as fx is strictly increasing in closed interval, semi-closed interval 2 comma plus infinity. Alright children. Let's see the value of f dash x when become less than 0. When the value of x minus 2 will become less than 0. Alright. If we transfer to this side, it will become x is less than 2. Or we can write as x belongs to open interval 2 to minus infinity. Right. So from here we can say that fx is strictly decreasing in the interval semi-open interval minus infinity to 2. Okay. Note down please. Let's see another sum children. Here the question says that find the interval in which the function fx is equals to x square e to the power minus x is increasing. So when the function is increasing, that means the derivative is greater than equal to 0. The value of the derivative, we have to prove that it is greater than equal to 0. Okay. Here we have to find the interval, right children? So the fx is x square e to the power minus x. If we find the derivative of the function, we apply product rule. This will become 2x e to the power minus x square e to the power minus x. Now this we have to show that for what value of x this f dash x will be greater than equal to 0. Right? We have to find the interval for which the function is increasing. Increasing means the derivative is greater than equal to 0. Now children, you can see here in these two terms you can take x e to the power minus x common. When we do that, it will become x e to the power minus x bracket 2 minus x greater than equal to 0. Now children, we know that the exponential function is always greater than 0 for all values of x, right? So we can say that e to the power minus x is greater than 0 for all x belongs to real numbers. So this has become positive. So this will not affect the result. So we can say that, therefore we can say x bracket 2 minus x must be greater than equal to 0. Now when we take minus sign common, this will become minus of x minus 0, x minus 2. Right? In the form of x minus we have written greater than equal to 0. So when we cross multiply minus or multiply minus both sides, this will become x minus 0 bracket in bracket x minus 2 less than equals to 0. Right? So from using method of interval, we can say that the value of x is lying between 0 and 2. Or we can say that x belongs to open interval 0 comma 2. Right. So if we conclude, the value of the interval for which fx is increasing is closed interval 0 comma 2. Alright children. Note down the solution please.